Okay, so hi everyone, and welcome to this session called Achieving Single Sign-On. So I will talk about single sign-on implementation in the context of third parties integrating with HealthShare solutions, namely Unified Care Record and the clinical viewer. Do I need to pose for your pictures? I'll send you that one if you want. That was taken just a few days ago. So I am Francois Floch, Senior Solutions Engineer. I've been with InterSystems for 11 years, about half time in the US, and more recently based in Switzerland. So here's the agenda of this presentation. First, I will sort of reintroduce the topic quickly, why we need single sign-on, what problem it is solving, how, and what are the different actors that are involved in a single sign-on implementation. In the second part, I will describe a few considerations for implementing different options and different protocols that are available. Then I'll quickly review a few of them and present 3 use cases of implementation with a short demo. And last, I will go a little bit beyond those demos that mainly focus on web browser single sign-on. Sorry. So hopefully at the end of this presentation, you will understand the main frameworks and options that are available for you and learn how you can use them to integrate HealthShare applications like the clinical viewer. So first, the situation. This is pretty much nowadays the clinician's lives. In fact, this is our lives. Nowadays, we work with a lot of different applications for a lot of different reasons and purposes. And if you take the example of clinicians, they may have they may have a solution for appointment scheduling. That doesn't. Does it work? That doesn't point. Oh, I have to point it. No, that doesn't. Anyway, so all of these applications are examples of what the clinicians can deal with, from appointment, billing, connected device on mobile apps, maybe a health information exchange like HealthShare, maybe an EMR solution like Epic. Maybe you will do some project work and write up stuff on Confluence, put on your vacation time on Workday, and find a way to get out of the office after the end of the day. This is not a random choice, by the way. Some hospitals actually ask for ride-sharing applications integrated with their environment because they want to have their patients that just get discharged to find a way to get home. So what happens when all of these solutions have their own application or website? The first thing that happens is this, the login screen. Now, I don't know about you, but this is the worst thing for me. I'm getting sick of all of these login prompts, the passwords. I learned recently that there's even a phrase for this, password fatigue. I don't know if you know about this. Apparently, a lot of people do studies on this and try to figure out what's the best way to have a million different passwords, but very small memory. Anyways, this is, I think I spent about maybe 15 minutes every day, just getting through all these gates, logging into your computer, starting your VPN, type another password, then get on your phone and validate whatever password I just typed, or get an SMS, and then find these 4 or 6 numbers that I have to type also. And then you get to your website for whatever of these applications, and you have to kind of start all over again, or maybe try to find a way to remember all of this. So just to give you an idea, how many of you were in the room find themselves in these situations and actually end up using the same password, because we all do that, or small variations of the same password? How many of you do that for a lot of websites? Nah, come on. I'm not the only one. The rest of you, you're just either big liars, or you have the memory of an elephant, maybe, or you just keep getting those emails. Now, mind you, I have no idea what the Zoho account is. I don't know if, but I needed 2 months ago to somehow log into something with Zoho, and I couldn't remember this password. If you ask me, I don't even remember what I changed it for, so that may just happen again tomorrow. Anyway, so this is the situation. This is why we need single sign-on, to avoid this mess and complications and resetting the password every day for something else because you tried the 5 passwords you had in mind, but it was the other one and got logged on or something, whatever. You're stuck. So what will single sign-on do for you? Hopefully, what will happen is that you will just end up logging it once, just once, and then have access to all your applications without logging in again and again and again and again. So it will do this really by sharing some authentication mechanism between all your applications and typically delegating to another solution that will be focused on the identity management. And you will end up seeing websites like this a lot, where you have this sign-in with Yahoo, Google, Facebook, whatever you name it. And instead of just remembering a ton of passwords, just have a few small number of accounts, maybe just one if it works, for you to remember. And the other applications will just get some user credentials from these single sign-on solutions, and you will just get through with this without noticing even that it happened. So how does this work? We'll talk mostly about web browser solutions. There's other ways that single sign-on is achieved for back-end systems in particular, but most contexts nowadays deal about web browsing, and single sign-on is achieved by doing some form of redirection, navigation between different websites that exchange credentials. These credentials will be passed around in form of security tokens. Security tokens would be either a random sequence of string that is just meaningless, or maybe cryptographic objects that will hold and represent information for the authenticated user, maybe more information like what is this user's name, email address, role, some kind of profiling, attributes, claims of the user in the sense that what situation is trying to assess for accessing a website, application context that can be useful. To do this and to have this work across a large number of applications, of course, we will need to use standardized protocols so that we all agree on the same framework. And that's where we'll introduce these technologies that I'll mention: SAML, OAuth, OpenID Connect, Kerberos, and a few more. So even though those standards have slightly different terminologies and a little bit different applications and options sometimes, you can draw a very common general picture where you have the same kind of actors. And I put here in different colors this terminology that can vary between some of these standards. But essentially, you always have a user, me, trying to go through a web browser or a mobile app to some kind of application, right? That's what we're trying to do. And we talked about exchanging security tokens, so there will be some kind of token service that will have for that will perform your credentials verification, so username, password, for example, and be able to return some form of security token to your application. That's really the basic story. Sometimes you will have something also happening in the back end, maybe do some additional validation or getting more information about the user. That can happen. And if you have then to go to a second application, same thing will happen. You will have the user trying to reach out to this application. It will obtain the credentials that may be the same token that was used for the first one, maybe a new one, because the context would be different, in which case the token service would deliver another set of credentials. And again, maybe there will be some backend channel. Now, you may ask, why did I put two applications here? Because it's exactly the same picture. Well, some use cases, you will have actually even, to some extent, these applications trying to talk to each other, exchange some information, in which case you would have some scenarios where they use these credentials to communicate and get some data. This is the case, for example, in Smart on Fire apps, right? Where you have the smart app here, using its own credentials to talk to a Fire repository and obtain patient data that it will use in its own application. All right, so that's the basic picture of what we're doing with single sign-on and how they work, all of them. When you try to decide which one of these solutions you're going to implement and what options you want to use, you will have to consider a few scenarios. The first most common one that we see is the distinction between what happens in private corporate networks, restricted networks, and the public internet. As a matter of fact, traditionally, you have a bunch of standards that have focused on the old-fashioned client-server approach that were designed for corporate systems, corporate networks, with some infrastructure solutions based on Kerberos, Active Directory services, LDAP, and so on. Nowadays, with the advent of more decentralized services, cloud services, public applications, you will have more and more public internet contexts where you want to use web applications, so you have to have protocols that are designed for web applications. That's the case of SAML, OAuth, OpenID Connect. I put Azure Active Directory, which is really the flavor of Active Directory that's online nowadays. But when you have to look at these two approaches, you will have to understand that they work in very different security contexts. In the first case of corporate networks, typically you know exactly everything about who the actors are, who the users are. You don't care, well, you care a little less about your network security because it's self-contained and you don't have as many threats, supposedly. Whereas in the public internet, you will more start with the behavior of, I don't trust anyone. A lot of things can happen. You can have malware here and there. I want to minimize as much as possible what kind of privilege I'm giving to an application. A second very common distinction that we make when you implement single sign-on is between what I call one-way single sign-on, where you have typically a central application or a portal application where you start, you log in and you start doing your work, and from there on go to other applications. So for example, if you start with your EMR, maybe your EMR has a link to open your health information exchange, another link to open your e-prescription software, another one for your appointments. The common thing is that you always start in the same place, and typically you use the credentials of that application that acts as the identity provider for all of the others. So we call this identity provider initiated implementations. On the other hand, and again, this is more something you will see actually in public internet scenarios, you would have a collection of apps that are very independent, that you may just open a tab and you're going to start your online appointment application. Maybe you weren't in your EMR to start with, you just started with that. And all of these applications, you may navigate from one to another in a very well, disorganized or independent manner, so that what you want in these situations is typically all of them to rely on a common shared solution for an identity provider that's dedicated to that. And in those cases, we implement what's called a solution provider initiated flow, where you go to that application, it looks whether you're already authenticated or not, and if you're not, it will take you to the identity provider before coming back with a user context. So this is just to summarize it, right? The difference between the left and right situation. This one will be typically simpler. It looks simpler to implement, but it works rather for a small scale of a small number of applications with one that is, central, and that usually you start your journey before going to other applications, whereas the other one is more suitable for large-scale systems where it's easy to add and remove external applications, and you have this sort of decentralized collection of apps working together. So this is just a couple of examples of considerations you have to make. Of course, when we start digging into security and other aspects, you will have some choices, but this is the main starting points, especially between I would say the legacy standards and the more modern SAML and OpenID Connect and OAuth implementations. So in the next part, I will talk briefly about a few of these standards and how they can be implemented with HealthShare. I will really focus on 3 different use cases. The first one, that is Integrated Windows Authentication. That's a framework that's provided typically in Windows Active Directory contexts. So we're talking about a restricted network, private corporate network with Active Directory services. And we will leverage these legacy standards. So for example, Kerberos and NTLM for single sign-on authentication, and maybe LDAP services for authorization. The second example I'll describe is SAML Web Browser Single Sign-On, and the third one, OAuth / OpenID Connect, which are very related standards. For these 3 examples, I'll do a short demo right after presenting them. So in the first case, what is Kerberos? Kerberos is really an old standard. See, it's about 40 years old already. And it's described in old public specifications files. So you see these old-fashioned drawings of computer and what looks like a laptop, but an old-fashioned laptop. I guess they already had laptops. That's a good thing. And one very particular thing is that you have this centralized authentication server, and typically you're assuming that you know exactly everything about your network. You know exactly who the clients are, where they are, what their IP address and server host names are, so that you can very tightly and securely describe how this machine is going to try to access a service on that machine. LDAP, Lightweight Directory Access Protocol, slightly more recent, right, about 30 years old. It is a standard that is tightly related to Active Directory and designed for directory services in more general fashion. It has its own authentication protocol, or it can rely on others. However, none of these is designed for single sign-on. And that's why I mentioned Kerberos before, because in a Windows AD domain, you cannot use LDAP for single sign-on. You have to use something else. And if you choose, for example, Kerberos doesn't do authorization, doesn't give you any information about the user. So you need something else, like LDAP services, to get some information about who the user is, what kind of profile they have, and so on. How the two can be used in this thing called Integrated Windows Authentication. What will happen and I will show you in the demo, is that you really log in once, which is at the moment you log in the OS, right? I log in into my laptop, and everything else is going to use Windows AD services to authenticate users, including in a web browser. This will work, of course, with HealthShare because Iris fully supports Kerberos and LDAP. And in this particular example I'll show you, we will even use the web server's Kerberos module for authentication, and then use and then use a HealthShare custom security domain for LDAP services to get additional user information. All right, so this is a demo. So I'm logging into this domain in a remote environment. This is an actual customer environment where we implemented this. So I open the browser, and I will try to get into one of the portal home pages of HealthShare viewer instance. You won't need French. This is a French customer, that's why it's there. All right, so you noticed I got logged in immediately. It knows that I'm Francois, right? And I can go right away into their customization of the clinical viewer. So for those of you who know the clinical viewer, this is the patient search in French, sorry. And you'll never see the login screen. In fact, the only way you will see it is if you try to log out. That's where you get it. But even if you get there, you can actually try to log in without even typing anything, and it will just log you back in automatically through all the browser single sign-on process. So how does this work in the background? This is an example of Apache implementation. If you know anything about Apache configuration files, you'll find here typical directives to register the CSP gateway, and you will have added a few configuration steps to implement Kerberos authentication. And this will include a specific file called the keytab file that connects your server, your Apache server, to the Kerberos ticket center. Once you're authenticated via Apache, the custom Z-authenticate will retrieve the user that got logged in via a CGL environment variable, and we will just pass this as the logged in username with some example here of non-printable passwords so that we can hand this over to HealthShare authentication. On the HealthShare side, the security domain that got configured here, we actually have a case where we even have two Windows Active Directory domains that are available for this computer. And they both use the same callback class, where we have implemented all the LDAP calls to retrieve your user's information. So you have here binding to the LDAP server, further down searching for the user that got authenticated, and a little bit further down in the unauthorized callback. The authorized callback, it will determine the user roles based on the profile that got found in LDAP. It's written in English, the coding, right?
Did LDAP basically pull from Kerberos?
So what Kerberos hands you over is a username, a unique username, and it will match an LDAP attribute that you specify. So I believe it's the CN or the SAM account name. And you will use this in the search to retrieve your user and his properties.
Yeah, okay.
Oh, that went a little fast. No. So, well, this is configured for HealthShare here, right? But this is a lot relying on implementation classes, because there are things like mapping the LDAP profiles and attributes to relevant HealthShare roles, and you know, if you're a nurse or a clinician, this you will always have to implement, right? So this is like this part here is something you will have to do or ask me to help you doing. The authentication, yes, right? Because the Kerberos thing, if you saw, the authentication part was only done in Apache, so it was not even HealthShare. It can be done in HealthShare, but I chose a way that didn't even use the Iris platform. Have to watch the time. So yeah, I'll show you. This is where I was getting the LDAP properties, LDAP attributes, and then going to the unauthorized. So having some mapping rules for the profile and whatever you need in HealthShare. It includes also, like I mentioned earlier, maybe last name, first name, email address, some other properties that are managed in your LDAP server and for which you may have some use in HealthShare. For example, an email, if you want to send notifications, or other things. So this is where we are. I was going to get back to the main login page and perform login, but this time track a little bit what's going on in the browser. And you can see the first response is a 401 unauthorized. And what really happens here is we get this response with a response header that says it's Apache that said you're not authorized. And there is this www authenticate that tells you that you have to authenticate to a Kerberos realm. The browser actually understands that. It knows that it has to go find this realm, find the Kerberos server, ask for an authentication ticket, and then return it with the next request in an authentication header. So the thing you just saw was the Kerberos ticket passed with authentication, and then Apache performed authentication, and the web page, you know, started to go into a session and returned the login page, the portal, sorry, the viewer page. So last thing I wanted to show you here is the user clinician registry. If you know about this in HealthShare, here I have a lot of users, so I think I'm filtering down. But basically that user got either automatically created or updated based on the LDAP server information. So you have, like I said, the first name, the last name, completely synchronized with your LDAP server, and your connection login ID that is here also synchronized. That's actually what you get from Kerberos, this ID here. And that is now registered in your LDAP and Kerberos domain in HealthShare. Does that make sense? So that's the example for integrating Windows authentication. Next, I'll go with SAML. So SAML is a more recent language. As you can see, about a bit more than 20 years old. It's a very different standard than all the other ones, completely open and much more assuming of open architecture, fully XML based, and well, of course, 20 years ago, everything was kind of XML, SOAP, and so on. There's one thing interesting in particular about the specification of SAML and the collection of documents that specify SAML. It's constructed as a bottom-up approach, meaning that it first defines your security token, the SAML assertion. Then, on top of it, defines messages for requesting that assertion or containing it as a response. Then it defines transport mechanisms for those messages. And finally, profiles, which are really how they are all organized for a purpose like web browser single sign-on, right? Because of this bottom-up approach, you actually end up having SAML assertions used in many more contexts than just web browser single sign-on, and you actually end up finding it in a lot of other situations. In the end, for what matters, for us and web browser single sign-on cases. It will end up being a very versatile profile that can be implemented for either IdP-initiated or SP-initiated, and with a lot of different variants for how you go from the service provider to the identity provider. You got credentials back, or maybe you want these credentials to come back on the back channel, and maybe even your request was in a back channel. So you have a lot of back channels so that you actually have almost nothing in your browser. But the point is that it has a lot of variants you can consider based on security environment, your assumptions about how vulnerable or exposed your end user may be to leaking those security tokens. SAML assertion, this is an example here. So the XML structure, you have obvious pieces like the cryptographic part with the signature, an X509 certificate that identifies the signer. What's interesting, more than all the standard stuff, is this part that contains the SAML attributes. And the SAML attributes can be a customized list of properties. This is interesting because this is not something you have in Kerberos or LDAP, the customization of properties, in the sense that this can be dynamically added for each time you log in with a different context, right? So I'm trying to access tomorrow my website, but I want to access it with some emergency hat. I'm in the emergency room and I want to have some access that is privileged or very different than the usual one. With SAML assertion, you can elaborate on these customizations much beyond just logging in and having a user profile. In HealthShare, you can implement SAML both as identity provider and service provider for us. The most interesting case and what we support natively is the SAML service provider, where you have this configuration page where you're going to say everything you need to configure for your service provider. So where my application, where do I want to go at the end when I'm logged in? What security domain is configured for this SAML single sign-on, and the identity provider here, for example, Microsoft Online Service, to delegate authentication to. And so HealthShare and Iris will also provide a complete set of SAML classes and utilities to handle, in particular, the customizations, your custom attributes, what to do with them, how to interpret them in the context of your application, and use them in a meaningful way. So next, a demo of this implementation of SAML. I did things a little differently here, where I start going to a different website than HealthShare. So here, the Azure portal, for example, but you can imagine it would be maybe your Workday or Confluence website. And what happens is that first time you go there, you're redirected to Microsoft Online. You've probably seen this if you have, like us, the InterSystems, one of those online services. To log in, you put your credentials, yada yada, and then you come back to your application. So here, the Azure portal or Confluence, or your RightShare app, if it is integrated, and you're logged in as your user. Now I open a new tab, and I want to go to HealthShare and the clinical viewer, and I'm logging with the SAML single sign-on endpoint that I've configured. And what's going to happen, hopefully, is that you get redirected to, again, microsoftonline.com, but this time you're already authenticated. So it's not going to ask you for credentials. It's going to give you everything you need, and you come back immediately logged in into your HealthShare instance. It knows who you are, and you have access to all your applications, like the clinical viewer, if it is what you've integrated. All right, so how does this work? Again, under the hood, I'll show you here the little pieces of configuration. So first, I'm going to log out of this viewer instance, and I'm going to log into the management portal part of that same instance with some admin account. And you will look at this SAML configuration screen I was showing you earlier, where we have all of this configured. So all the parameters of your application, which security domain it's using. That was the endpoint that triggers the original single sign-on redirection. You have here the target page where you end up being after you've achieved single sign-on. And so the security domain with the callback class that was picked up from the HealthShare configuration. On the identity provider side, you'll have some certificate. So that's mainly the trust relationship with and what allows you to sign your messages. And the login microsoftonline.com endpoint that is used for your specific application. So that's something you have configured on the Microsoft Online website to achieve single sign-on for this particular application. If you look next at this authentication callback class, what really it does is really just focusing on these assertions, attributes that I mentioned that are the customization part. And you always have to do this with single sign-on, is find a way to map all this information to something relevant. So for example, this is the last name, this is the first name, but they use British, surname and given names. Who would have known? And the display name, Francois the Floch, that I'm going to use to display something on my viewer page. You have, so mapping for the identity, login, mapping for other attributes. So you will have a little further down the user creation class that will dynamically create the user if it doesn't exist, or update its properties. And how you determine the roles, the HealthShare roles for your user. In this particular case, I give everybody the clinician role, but again, I could have mapped, any relevant attribute to a series of different roles in this callback method. All this is documented in the SAML single sign-on implementation in HealthShare. All right, so next, I'm going to show you the same thing happening, but from with the network debugging tools, so that we can see a little bit all of this happening in real time. The login single sign-on happened again. You find the user here again. And we can see that we got into a series of redirections between the HealthShare website first. The HealthShare website, in this particular case, redirected to loginmicrosoftonline.com with an HTTP post. And the HTTP post included in the payload what's called the SAML request. And the SAML request contained details about who is trying to access this single sign-on website, for what purpose, and so on. So you have here this SAML request, and you can put in your favorite notepad or whatever XML reader, and you'll find here this authentication request. So that's the XML. We're going to make it a little bigger, right? And it will have some information. So this is the login Microsoft Online destination. This is who is trying to access it. It has some cryptographic information to identify securely the application. When MicrosoftOnline.com has verified all of this, it returns a SAML response with the same mechanism, an HTTP post with a SAML response argument. And again, you can look at it right away. This is the SAML response. You have the SAML assertion that starts here, and it will have basic information about the user and credentials and all these custom attributes with the British version of the names, and the last name that I want to use, and maybe even other things you can configure on MicrosoftOnline.com. So with this, HealthShare with validate the SAML response, validate that it came from Microsoft Online. You get authenticated and you get back to your home page, and you receive the home page right away. Next thing here, like before, I want to show you is the clinician user registry in HealthShare, where you will find that have been added or updated. You'll find some information I've imported, like some unique identifier that you can find in this particular case, the email address that you find here that was mapped from an attribute right here. So again, this is to illustrate you have some work to do to understand, what's in this, because not all the providers follow any standard. This is the part that is not standard, all these custom attributes. All right, so that's for SAML. I'm running out of time. I'm gonna do quickly the last part, which is OAuth and OpenID Connect. So OAuth, we're going really closer and closer in time. OAuth is starting to be a very recent standard. It's less than 20, maybe 15 years old. We're no longer in XML territory. This is all HTTP REST based. Interestingly, the specification has a completely different approach than SAML. It goes top down, meaning you start with a use case, what you're trying to do, and you go all the way down. So from this abstract protocol flow to things like the security token, which in this case is an access token. OpenID Connect, basically, nowadays is just completely disconnected from OpenID and something that is just 10 years old, really recent. If you compare this to Kerberos, that was 40 years old. Recent standard, it basically is based on OAuth too, but it just adds a few more constraints. For example, using JSON web tokens for sure, whereas it's just an option in OAuth. So you end up having a combination of the access token and ID token. The ID token will have some mandatory information that will explicitly identify the user. Like SAML, you will find also that there's a couple of options that are available for the implementation, going from the simplest case here to more complicated situations where you have more things happening, maybe some back channel stuff. To add some security features, like in SAML. The JSON web tokens look like this. There will be 3 parts when you decode it: header, payload, and signature. Payload is obviously what we're interested in, and it will contain mandatory information, but also the optional information, as we found in SAML, like family name here, given name. They still love British stuff. And some other information that you may want to map to something relevant for HealthShare. I'll pass on this quickly and just go to the demo. So, same scenario again. Start with my browser, and I'm trying to access HealthShare. This time I'm not going to start by another place. I haven't logged in yet. So I'll just see the redirection happening and delegated authentication to, in this case, also Microsoft Online. All right, so this redirects you to Microsoft Online, where you get a login prompt. Sorry, it's still in the French context. I hope you get the idea, though. And you probably, if you use Microsoft, you find this familiar again. You type your password. In this case, I used the one we use every day that also gives you an SMS every day. Where you have to do some verification. So that's the login part. That's not HealthShare at all. And after you've done this, you come back with your credentials back to HealthShare. It will do single sign-on. Yeah, that was a 2-factor authentication. Yeah. Whereas the case just before with SAML was just one time I typed the password. It was a different configuration for the Microsoft Online. So you get logged in, again, automatically, same story, and you can go on with your life, do stuff in the clinical viewer. Now, how is this configured in the background? You have this OAuth web application that I've set up so that I have the custom login page here. It really just extends a standard class, a person OAuth to login. And the only thing added here is some parameters that identify your application, identify your OAuth client configuration before you get redirected to your OAuth server. That's, in this case, is Microsoft Online. It has also some audience property in the request because it's requested for Microsoft. The OAuth client is configured here, all in the portal. So you have the OAuth server configuration. That's all information that's usually automatically retrieved from Microsoft. And you have your client configuration here, also with some encryption configuration, client ID, client secret. Again, stuff you configure in Microsoft Online, and you configure here afterwards to match your authentication credentials so that the application and the other one trust each other. So once you pass authentication, what happens? You end up in your delegated authentication environment, and in the get credentials, what we're going to do is retrieve the OAuth client, retrieve the access token that is automatically retrieved by Iris, and get the access token and the ID token that were retrieved in this process. And so in this case here, you will do some additional validation. So validate, the cryptographic parts, validate that it has all the necessary information for your application, and you'll open the JSON objects. These are examples here. And same as before, you will have to map these tokens to relevant information for HealthShare. Maybe find, which domain this should be mapped to. Where's your last name? Where's your first name? Where's your email address? All the stuff. Again, typical implementation, but you have to map those because there's no standard for these extra pieces of information. Oh, and there's also the roles here. So there's one attribute that in this case, I map to a HealthShare role. We're going to do this again, like before, but looking at the network activity while this is happening. So you have, as expected, very similar scenario as before, where you start with your web page. It finds that you're not in the right security context. Does a 302 redirection in this case, with the location here set to microsoftonline.com with all the URL parameters that are needed, which client ID, etc., etc. You get then to the Microsoft website. That website is where you'll do your login, password, two-factor authentication. And when it comes back, it will redirect you back to the OAuth response class, which is a built-in class to handle OAuth. That class will retrieve what's called an authorization code, exchange it in the back channel for an access token. And based on this, then HealthShare will be able to log in, and you'll just end up in that page that you've requested. Now, you don't see the access token on the browser because I mentioned here it was set with a back channel. So I set some debugging globals here to look at this access token, just for comparison with what we had before. So you can take this access token, put in your favorite website that decodes the access tokens, and does some night color coding of header, payload, and signature. In this case, the payload is here in the middle, and that's again all the information that we retrieve. The email, first name, last name, the roles that are here that you can use in your implementation class for mapping to relevant information for your application and HealthShare portal. So last, we'll just quickly look at the user clinician registry. Again, like before, we end up with a user that is based on the OAuth credentials with some unique identifier. The email address we retrieved from that token you just saw, and the credentials in the OAuth domain. You can even find here the role that got mapped. All right, I'm way over time, right? So I'm gonna go quickly over there to the last slides, but I think the demo was maybe the more interesting part of this presentation. This is just a summary of the differences, and I highlight a lot the timeline because you know, you have to find a good balance between the old legacy profiles that are kind of rock solid, but not necessarily appropriate for the modern, you know, context of web applications, cloud apps, and so on. There's other context, just to mention briefly, we didn't talk about single sign-off, but that's one thing that comes usually right after single sign-on. So how would logging off of HealthShare actually log you off of Microsoft? So each of these profiles has a way to do that. And I mentioned very early on the non-interactive things you can do also with single sign-on. So not based on your browser. This is what you have in Smart on Fire case, but you also have some other use cases where these standards can be used for server-to-server delegated authentication. So that's it. I added here just reference to a session that talk about security in HealthShare. One interesting thing in that other session is that HealthShare in the latest release has some integrated OAuth single sign-on between the HealthShare instances. If you work in a complex environment, that's very useful. And so if you have any questions, other questions, you want to see the video again? All right. Well, if you need anything, thank you.